Hello everyone. So just to change things up, today I'll be narrating in my video and we're going to be solving the question number one from the weekly contest that was conducted today on LeetCode. So let's get started. The problem goes like we have to find the minimum cost to reach every position. So initially we are starting from the very end of an array uh, and we have to swap places with anyone in like any other fashion. We can go to the first place first and then go somewhere else and everything we can do. And we need to find the smallest cost that we need for the swapping of places in total. So let's say we are given this array 5, 3, 4, 1, 3, 2, and we are at this part, the last part. And say we want to go to the first position. Whatever we do in the first position, we can't get anything less than 5. So let's go with 5. For the second position, if we want to go from 2, it is showing us as 3 directly if we go. So yeah, 3 is also the minimum cost. If we go from anywhere else, we would at least need 3. So if we say 3 is the minimum, we keep the 3. Then we say about 4. So now the caveat or the main point of this question is that you can, if when you're swapping forward, you need to pay these costs, but when you're swapping them backwards, you don't need to pay any costs. So 5, 3, but if you want to go to this position, it's requiring 4, but you would never need 4, you'll only need 3. And for this one, you can just directly go for the 1. For this 3, again, you have 1 here, you can always go back to 1. So that would be the process. Thinking about this problem, a kind of a greedy approach, no, not greedy approach per se, but an approach where we are just exploring all the swaps and we're just keeping the minimum value could be a valid approach because we have to return this particular array of the minimum costs. And I think like starting from the very first position would be advisable because when we go to the first position, the minimum cost would be reached in n steps, and beyond that, for every other step behind the first one, we can use the minimum as the first step. Like if any other step is less than the first step, then we can have it, or else we can't have it. In that sense. Okay. Anything else that we are told in this question? 1, 2, 4, 6, 7. No, we are not told anything else in the question. So let's just once try to visualize how we are going to solve this problem, and then move with the solution. So let's just walk through the example that we have been given. That is 5, 3, 4, 1, 3, 2. Okay. So we initially can put the cost to reach the first position as 5 as the minimum cost, because it could be, let's just find out all the values. First step that I am suggesting is we go for cost calculation for step 1, right? For this one, from this position directly it's 5. Okay. Or what we could do is we could go to 3 and then go for 5, because the cost will be the same. We first will add this 3 plus 5 kind of the whole equation. We'll add 4 plus 5 to the equation and all. So usually the minimum cost, if all of these are positive integers, we can assume the minimum cost to be 5 itself. Then for the subsequent one, 3, we will have 2, 3, 1. For any other swap, you'll need to add 3. But for this, you won't need to add 3. So it is 3 or it's 5 itself, because the backward slash when you the 3 is okay for us. So we go with 3. Then for 4, we have the option of 3 5, 3, and 4. Because 5 can also come, 3 can also come, 4 can also come. Here we'll choose 3 again. For the next one, we have the option of 5, 3, 4, and 1. Here we go with 1. Next, we have the option of 5, 3, 4, 1, 3. Here we go with the option of 1 again. Then we go with 5, 3 for the 4, 1. I think this should be remaining the same, right? Because the cost, no, it will become 1 itself again. So we will get our solution as 5, 3, 4, 1, 1, 1. Just to find some edge cases that we may encounter in this. What will be the edge cases? Well, let's say we are given a single element, let's say 5. I think we should just return 5. We are given an empty array. I think we should return empty only. I don't think these are the constraints, but let's just check if anything else is mentioned regarding the constraints for the problem. Okay, the cost length would be greater than 1, that is given to us, and it will be less than 100, and all the costs would be between 1 and 100. So these two things are important, and we have them written down. Cost would be between 1 and 100. Any individual cost, so the individual cost, they would be between 1 and 100, and the costs, like the array, would not be empty. We don't need to care about this case, and it would actually be greater than that as well, because it's in this thing. So I think we won't even need to consider this, but we can just put it there. So this would be the discussion for how we would approach this problem, according to me. And let's try to code up the solution first and look, with the sample test cases we have there. Okay, let's start. Let me just first reset it. So for I, come on, then you can write. Let's just initialize the minimum cost variable before we enter this loop. Minimum cost is equal to none. Okay. Then we say if num. Actually, if we keep minimum cost to be num now, we can't use the like comparator operator for I. Let's go for I in range 1 to length, and just say cost is equal to num 0. Right. Just go with if length num equal 1, return num. Do that again. And then we're just going to go if num I less than equal to min. Is equal to I. If num I is less than min cost, so we go with min cost is less than num I is equal to num I. I think we have an else statement here. If they are not less than, that means num I needs to be updated, right? If the num I is greater than that, else num I is equal to min cost. Based on this, we should get num list. So what we're doing is, if it is, let's just walk through one example. we have this 5, 3, 4 example, the one that is given 5, 3, 4, 1, 3, 2. So first it goes with min cost gets to 5, and because len num is not equal 1, so it doesn't return num yet. But it goes for the next loop, wherein it goes for num1, that is number 3, and it checks if it's less than number 5. It is not less than number 5. So wait a second. If num I is less than cost 5, if 3 is less than 5, okay, if so that is true. If 3 is less than 5, then the min cost gets updated to 3, and we just move on because we can't change anything there. Else, when we go to, let's say, 4, there the min cost is greater than mi, so we get there 3 as well. Then we go to 1, we let 1 remain there. We go to 3, we change that to 1. So that example we can walk through. 1, 2, 4, 6, 6, 7, I think that also works. So let's just try to run it first. Okay, we're facing some problem. Okay, cost was the array. I made a mistake. I named the array as num for some reason. Process some array. Cost. Okay, so it's passing the test cases. Let's try to submit it. Okay, the example was submitted. GG's, I guess. Beyond this, I'll work on the next problem. I'll meet you again in the next video, I guess. Bye.